I'm the calculus professor, and today I'll be talking to you about sequences. Welcome back. Today I'll be talking to you about section 8.2 on sequences, and we're going to start with problem number 11 that asks us to find the limit of the sequence 3n cubed minus 1 divided by 2n cubed plus 1. All right, so when we say find the limit of a sequence, what we're really asking is, let's take the limit of this sequence as n goes to infinity. So what I want to do is I just want to set up a limit as n goes to infinity of 3n cubed minus 1 over 2n cubed plus 1. So the question here is, do we remember our limit rules from Calculus 1? And if we do, this is a relatively easy limit. But I want to go through this two different ways so that you can see both the ways of doing it, the long way and the short way. So first let's start with the long way. And what I can see here is I have the same power of n on top and bottom for my highest power of n. So n cubed is the highest power on top, n cubed is the highest power on bottom. So what I could do is I could just divide both the top and the bottom of that fraction by n cubed. If I do, this is what I get. I get the limit as n goes to infinity of 3n cubed minus 1 over n cubed divided by 2n cubed plus 1 over n cubed. And notice, since we divided the top and the bottom by n cubed, really I just multiplied by 1, so everything is the same. All right, now I could rewrite. So let's write this as the limit as n goes to infinity of, if I break this top up into fractions, then I have 3n cubed divided by n cubed. That's just 3. Then I have minus 1 over n cubed. So minus 1 over n cubed divided by, on the bottom I have 2n cubed over n cubed, which is otherwise known as 2. And on the bottom I have plus 1 over n cubed. Plus 1 over n cubed. All right. Now, if we take the limit at this point as n goes to infinity, then this 1 over n cubed goes to 0, and this 1 over n cubed also goes to 0. So this guy goes to 0, this guy goes to 0, and I'm just left with 3 over 2 as my limit. And that's what we're wanting to get as the answer of this guy. What's the short way? If we remember that when we're taking the limit of a rational function, now a sequence is a function. It's a function, though, where only the integer values of n are plugged in to that function. But we can still treat it as a function. And we knew that the limit of a rational function as n goes out to infinity, if the power of n is the same on the top and on the bottom, then I can, at least the highest power of n is, then I can just take the coefficients out in front of those highest power terms and get my answer. So since n cubed is on top and n cubed is on bottom, then the coefficients out in front, 3 over 2, that's just the answer to the limit. And that's kind of the shortcut way of getting to this answer.